we're in a unique time when it comes through to, before we're drawing power from utilities, and we have a focused interest to need power from a centralized location. Now, we can take that power and put it exactly to our sites. We can actually have the technology to portray it all on a dashboard through, the Internet of Things and different software mechanisms. So with that being said, I'm going to unshare my screen here, so we're not focused on what's wrong with my face, and more on the presentation here. Okay, awesome. So as I mentioned, like, sustainability can be dived and cut up into so many different ways. So it's either like, hey, are we trying to buy recyclable, sustainable recyclable materials? Are we trying to, reduce waste at our facilities? But when it comes down to it, the majority of sustainability measures that are out there is power and energy. So the main focus of this is, on a sustainability metric, is we're going to focus on power and energy, on how we can transform our energy demand to be used to be 100%, or not necessarily 100%, but majority, hopefully, to be clean, green energy. So the opportunity that we're eventually going to talk about is, how can we, our society and OneSource maximize our profitability as well? Because I like to say sometimes where it's, it's like Jerry Maguire, show me the money. So we can go to an organization, a facility, but at the end of the day, it's like, are you willing to invest into a $5 million, $10 million, $20 million, $500,000 energy project? And of course, that's scary. So sustainability is a focus and initiative that we all want to head down, but there's a payment for it. And so we can show, what we've built and what we can show is, how can we maximize profitability for your company utilizing clean, green energy, and to make sure that investment is as low as possible. So yeah, we're going to dive into clean, green energy part, having our buildings and locations, areas be more sustainable, while at the same time seeing what are the grants, the funding, and everything else that is out there, and how can we grab those to, make sure our projects are sustainable, but also essentially pencil out in a great way where it makes sense for everybody. And what we've learned too is, there's a lot of, startup companies out there that try to focus on this. So it is very, very beneficial to work with a company that's been around for 50 to 70 years, have a lot of resources and a lot of experience in this field. So in this presentation, we're going to talk about OneSource Energy, who we are, what we do, a little bit of the market forces, like what direction is our society moving in based upon what, our federal government and what direction they want to steer us in. And also, what is a microgrid? This is a sexy term out there, but what is it? How do we make it work? What does it look like? We're going to go into that. And then we're also going to talk about an energy project. So we're going to do a little mock project, like what it would look like if, here's an opportunity, and how do we make it happen from the ideas into exactly construction and implementation. So who we are, Sonopar, we're based in France. We are a $27 billion company. We're considered the largest distributor in the world. So we have resources all across the world and can do projects all across the world. So mainly a lot of our, we're a distributor of our core basket of goods is mainly on the electrical side with utility products, industrial, and as now with my group and my team, we're evolving onto the energy sector. So OneSource, there's a different operating company within Sonopar, and so we're directly located in Mexico, Hawaii, California, and Arizona. But of course, like I said, we have the whole world where we can operate. So a little bit about us. We have a state-of-the-art energy department. And with that being said, the reason is that we're a distributor. So we have multiple different resources. We're fully vertically integrated with carports, battery storage, solar, wind technology, lighting, anything. We have multiple partnerships on a software level and a hardware level. So we can essentially cater the best solutions essentially for specific locations and projects, instead of not just having a baseline aspect for that. So we do full design, full construction, full procurement to make this all happen. We've done over $70 million worth of energy projects in 2020. We've been lucky enough to win some awards as we've been going down this road. Last year, we won Best Integrated Solution by TED Magazine with our energy package that we've developed here. In 2019, we won Best Marketing Campaign with Tasha from our team with her great work. And that was with our EV charging solutions on how we can combine the software and the hardware all together as one fully integrated experience. For me, I've been lucky enough to win a TED Magazine 30 Under 35 award a couple months ago. And again, I'm just trying to mention this just to create some credibility out there if people don't know who Sonopar is. So past projects, I wish I could show all the logos and the projects that we've done, but for liability purposes, I'm just going to talk about the verticals. So cities, we've worked with cities, water and power utilities, universities, school districts, industrial and manufacturing, commercial property, wineries. So if you like, Paso Robles Cabernets, we had a big part in making sure the wine is still fermenting at perfect temperatures during fire codes, transportation authorities, and also government agencies. So as we're talking about the different sustainability measures, what we can do to become energy efficient, but also utilize clean green energy, mainly our basket of goods that we focus on. We have strategic financing strategies, HVAC systems, EV charging stations from DC fast charging stations to standard level 2s, commercial, industrial, and utility battery storage, commercial, industrial, utility, solar, carports, generators, lighting. We do engineering, wind solutions for wind technology, smart building software, so we can have all this information portrayed on one dashboard for our facility managers, rebate consulting and management, and of course, the turnkey solutions to make these projects all come together. And again, we offer a one-stop shop, turnkey offering, where a big value is that you deal with one person for the whole entire time. And there's not going to be any communication and any muddling. Should be we try to make it as seamless and easy as possible. So we'll design the project, we'll model it, we'll do economic modeling. Like I mentioned, we do hand designs, and we create templates where we actually, since we do it by hand, we can show exactly why we're sizing it, why we're designing it, and then work collaboratively with our customers to make sure it all makes sense. And essentially that, we can show proofs of becoming sustainable, but also showing proofs of how much money that can be made. At the end of the day too is, we are businesses and we do want to increase our profits. We'll collaboratively select manufacturers. We do consulting work, labor and commissioning, as I mentioned, the one-stop shop. So, what direction are we moving into? So the federal government now, we're moving into renewable energy initiatives. And the beautiful thing with that is that, if any of us are familiar with rebates only last a certain amount of time. And so as it becomes more, on a macro scale, more adopted, rebates aren't going to exist because these, the government, these utilities don't need to offer incentives to do these projects. So now is not trying to promote anything, but now is the perfect time for energy projects because there's so much rebates and funding that's available. So with that being said, President Biden's plan passed to have over $500 billion worth to upgrade the electrical grid, and also including that to have over 500,000 electric vehicle charging stations in the very near future. And so in the beginning of, so this is kind of just a little slide to show, how much we're investing and moving a society to clean green energy. So this is a metric and study done by Bloomberg, and they said in the beginning of 2020, over $117 billion has been invested into renewables. Just by in that 1 year time frame, that was supposed to grow to $700 billion. That's around a 6 times growth of investing into this. So this market is here, and we're coming fast. And with that, we mentioned battery storage, and it's somewhat of maybe a newer idea or concept for us. But at the end of the day, the reason why electric vehicles too are becoming more mainly adopted is because the battery technology is finally becoming there where it actually works and makes sense for everybody. So battery storage is not going anywhere. So over the next 30 years, it's supposed to rise by 18,000%. So it's not just some kind of little fad technology that we're all moving in. And so the great thing about having sustainability and, of course, clean power is it provides reliability. And unfortunately for natural disasters, it is a huge, huge benefit. In the state of California, where where I live and we work in a lot, the utilities can just shut down power based upon fire dangers. And so, what if you're a manufacturing facility? What if you're a hospital? There needs to be reliable power that it needs to be drawn and needs to be operated on. Millions of dollars can be lost, lives can be lost. Most importantly, floods and hurricanes, and of course, the whole thing in Puerto Rico, unfortunately, was that the hospitals didn't have power, and so having sustainability, having solar, battery technology, We can harness energy from the sun and make sure we have reliable power for even the most hardest circumstances that are out there. Okay, microgrid. What is a microgrid? What is this microgrid thing that we're all talking about? As I mentioned before, it's basically to have a grid in a centralized location. So utility grid. So you can have a large-scale building, create a microgrid, boom, you have a utility. You have power. So how I like to think of it as it's an ecosystem. It's an ecosystem of energy assets all working together and working conjunctionally with one another. So this is kind of a beautiful thing where the Internet of Things and technology comes from, because we can put sensors and different software technologies that can communicate with these energy assets and go, okay, what is the cheapest cost of power right now at 2 o'clock? Okay, is it solar? Is it battery? Is it wind? Oh, it's battery. Let's close the circuit. Let's use the battery energy and have that energy basically power our building essentially. So a lot of it's intermingling communication to find out what the best opportunity to use energy within this microgrid. So there's two kinds. One that you're still connected to the utility. And again, so the utility now joins within that microgrid together. And then also there's another one where you're specifically, you're separated from the utility. You're off the grid. And so that is essentially that the only power that you can draw is the ecosystem that you can create. And the values of a microgrid, of course, is the increased profitability. As we mentioned, it's a dance between all these assets to see what is the cheapest opportunity that is out there to utilize power. Maximize profits per square foot. If you have, roof space, parking lots, you can create revenue for them. And of course, energy resiliency and reliability. Your manufacturing facility, you need power. Hospitals, it gives you that sense of comfort when power is needed essentially. And of course, sustainability. It's forward thinking. We're helping the environment. It shows everyone that we do care about our communities. And so, so solar and batteries don't mean microgrids. So there's like kind of a misconception when we add that in there. So an example of a customer can become, I want to be sustainable, so I want to use solar and battery, but I also want to make a fast financial return. So the difference is that the design is not necessarily to fully encompass the whole power draw. So this example, it shows in the tan that the customer is getting killed with peak demand charges from like 4 to 9 o'clock. So what that is telling us, hey, let's use that battery during 4 to 9 o'clock, and now I don't have to pay times 2.5, have my energy bill skyrocket during that time. I can rely on the battery power that the solar provided during the day, and we're still being powered by clean green energy. As I mentioned, a lot of the solution is, majorly it's wind, solar, and batteries, and of course generators, cogen. We can put flywheels in there. These are the main nuts and bolts of how we're focusing to be clean green energy. So about Lord One Source and how we're unique and how we have a different differentiation compared to the market. As I mentioned, we're fully vertically integrated. We do essentially everything when it comes to the software and the hardwares, and that's basically just between building management systems to software that communicates with our solar, with our wind, with our battery storage, with our EV charging stations. We do all of this work all combined together. And one thing that we're really proud of is we custom design every one by hand. We've seen energy softwares that are out there, and we've seen a lot of flaws. And we're like, you know what? We're not going to put our name behind that. So we design everything by hand, and that's how we know exactly that we can be confident that this customer has the best solution that is exactly tied to what they need. And like I mentioned before, we're product and software agnostic. So to work with one manufacturer with a microgrid type of project, you're tied in to only using their product. And the great thing about what we can do is we have resources with all these different products. So a manufacturer may be great at this, but they may not be great at this, but they're trying to use their product for that. We can be totally unbiased and focus on the best solution. And the rebates and grants, so they're different throughout every single jurisdiction. There's a lot of federal opportunities that are out there, but it is very important to know exactly any energy commissions in your jurisdictions, what utilities in your jurisdictions, what is being available. So how can we promote these and how can we make a lot of money and also help the environment? So we have a full team that will go into your jurisdiction. If we have an opportunity with any of you, we have a team that will go into any jurisdiction, will research and find any rebates and incentives that are out there, and that will cater also our designs to make sure that we maximize that rebate and that money opportunity, depending on what our strategy is. So, okay, so we have a project, we have an idea. How does it work? How does it look like to actually take these things, take these ideas, and how do we make it happen? Let's dive into it. So let's say we're working with an industrial company. Okay, industrial company. We need to gather data. So let me see some energy information that you have. So let's gather all of that. Okay, we have it. It looks good. This is what we're looking at. Now let's create a concept. What is your goals? Is it a microgrid? Are you just trying to be sustainable? Are you looking for a quick financial payback? What is the main play for the opportunity that we can do with clean green energy and for energy savings? Okay, we figure out our strategy. Now let's design it. Let's design it. Let's make sure that we can visually show you where everything is going to go. Let's make sure it all checks out. We're not going to have any blockades or any obstructions in the way. That looks good. We're going to engineer it. We're going to make sure that it makes sense structurally. We're going to make sure it makes sense electrically, so our ideas and our concepts can actually happen. Then let's make it happen. Let's implement it. Let's procure the right products. Let's construct it. And then, of course, at the end, let's keep on, project managing this project, and then we'll make sure that we're sending all the paperwork to the proper authorities or jurisdictions to make sure that we get all of our rebates and our funding that's available for projects like this. So what we do is, so of course we'll take an energy profile. We'll design. We'll take it. Sometimes a lot of customers use 2 different energy companies and have multiple different meters. So we'll take all of that, and then we'll digest it and hand do certain breakdowns, and we'll find out what are the best ways to size systems during specific times, or just what size is going to be the best for a specific opportunity. And then, of course, all right, what are the rebates and the incentives? So now we're going to look into we have your energy bills. Now we're going to research the rebates and incentives are available, because now that can help us formulate our design based upon how much money we want to be able to obtain. Or, of course, again, if it's a microgrid, it's a little different strategy, but at least we know we're doing the right thing to have a great project. And then we'll show, we have a full detailed proposals, but I wanted just to show just some kind of financial metrics that we can break down. A couple customers want to see revenues per square foot, internal rates of return, net present values. We'll break down all the information to make it as visually transparent as possible, so a CFO can just take 2 seconds, show me the one-pager, and then see if it makes sense or not without reading a 25-page document. Okay, so now we have that. Everything looks good. Rebates look good. Energy bills look good. Now let's design some solar. Let's put some solar on your rooftop. And this is here's what it will look like. This all looks good and makes sense. For this specific project, the customer wanted to see 2 different size solar modules, so we're able to give them that and portray that information to them. Okay, so here's our look in. Oh, we want to add some carports. Okay, great. Let's add some carports. Let's maximize our revenue per square foot with our parking lot, and also get some offset to become more sustainable within our energy bills. So we'll do that. And then we'll design the carports to the exact specified manufacturer's dimensions, so we know exactly what it looks like. So it's going to be a clean and easy engineering and permitting process to get this project going. And then battery storage. Okay, so we want to add some battery storage there. And so for this industrial customer, for example, they have a lot of manufacturing equipment. Let's just say that their energy demand spikes at 10 o'clock, and so now, basically, they want to offset that energy, because now their energy bills are ×2, ×3, just based upon that one time frame of the energy spike. We want to bring that down. So how can we bring that down? All right, we'll formulate a 3-megawatt battery. It's a big application. It's going to be around a 40-foot container, and you can kind of see what it looks like. It actually does a really good. It looks really good. It looks better than this picture on the container side of it. And then we'll program it to make sure that you don't have that high load during that time, but also we can also program it to do a time of use rate as well. So let's just say we'll commission it as priority 1. Let's do load shedding, and then we'll have the technology through the software. We'll program it to be priority number 2. Let's do time of use and use that power during like 4 to 9 o'clock. So now we can get 2 functions and 2 values out of our system. Okay, let's do it. All right, so I'm going to show you what that looks like. So now we're going to give you we have our 2 strategies that we want to use. So the one on the left is going to look like how we can bring our load down for that given time. The blue shows that, hey, this is your original spike, and now let's bring it down a little bit with the green, so you don't have too much. You don't have too much energy bills. And of course, on the right, it shows where the battery comes in towards the end of the day, around 4 to 9 o'clock. And of course, here's a little visual aspect of discharging. So it shows the E-gauge meter, and that is essentially where that's the brains of this whole system. So software is going to communicate to this battery, say, hey, we have a high load, or we have, hey, it's 4 o'clock during our time frame. We want to release that energy from the battery. So the e-gauge meter communicates to like a software program inside the system, and then it basically goes through the process, through the inverter, through the panel, and now that facility has energy at its availability. So the one thing that's really important too is that if we're doing a microgrid, we need to make sure there's no lead time or delays when that's happening. Because sometimes for a pharmaceutical company, if there's any lead time in that energy, the whole batch is ruined. So we need to make sure the software and the connections are actually perfect, or close to being as fast as possible, so we don't lose any batches or anything any disruption is not going to cause a problem for anything that is used. So within this technology, they actually can use autonomous car technology for how fast, for what technology that can be used for how fast the transfer from solar to battery could actually be. It's actually really neat on the products that's being created. So we also do, so part of it, away from our example, we're moving more towards electric fleets, electric buses. We can design charging stations for specific trucks, fleets, buses, their specific battery sizes. And so for those battery sizes, we can get it into a schedule close to under 5 minutes to be conservative. We can get a realistic idea of when your fleet will be ready by selecting the right charging stations for your application. We also do strategic financing. We can essentially have, we can turn buildings into power plants. And if a building owner wants to charge, their tenants power, we can formulate the right resources to make sure that they essentially can become a utility, and they're making, they become their own utility, and they're making quite a bit of profit by also being very, very, very sustainable.